Hello and welcome to today's lesson. Today we are going to continue with looking at the fundamental concept of probability. And today we are going to be looking at the DAS. My name is Jay Aquidaba, and as you know, this is Math Made Simple. Let us start. A DAS is a cube with 6 sides, and each of the sides is labeled from 1 to 6. So when a die is true, we have 6 outcomes. So the total number of ways that this die will show up is the total number of outcome. So we say the number of outcome will be actually 6. So with that in mind, and let's see what we can do here. We say a DAS is true. What is the probability of throwing A 4, B an even number, C a number less than 5, and D a number greater than 6? Okay, so probability is the event divided by the outcome. So for each of these problems, what we will want to do is to determine the total number of possible ways of that event. All right, so for a 4 to appear when a die is true, if you look on the dice, you have only 1 4. So there's only one possibility for a 4 to appear. So that one possibility is the event. So we say the probability of 4 being true is equals to 1 over 6. And we know 1 over 6 is just the same as 16.7%. So let us look at B. B, an even number. So when we throw a die, what's the possibility or what's the probability of an even number showing up? So if you look at the dice, we have 2 is an even number, 4 and 6. So there are 3 even numbers. So it means there are 3 different possible ways that we can obtain an even numbers when a dice is thrown. So it means those 3 possible ways are the event. So the probability of obtaining an even number is equals to 3 divided by 6. 3 divided by 6 is 1 over 2, which is 50%. 1 over 2 is 50%. So we have 50% chance of obtaining an even number when a single die is thrown. Okay, for C, a number less than 5. So numbers that are less than 5 on the dice are 1, 2, 3, and 4. So these are 4 different possible ways that we can obtain a number that is less than 5. So that represents the event. So for the probability of obtaining a number less than 5 would be 4 divided by 6, which is equals to 2 over 3. All right, so and we know 2 over 3 is the same as 66.7%. Okay, 66.7%. So we have 66.7% chance of obtaining a number that is less than 5 when a single dice is thrown. Let's look at D, a number greater than 6. Now, in how many ways can we obtain a number greater than 6? In fact, there is no possibility because on the dice, the highest number we have on the die is 6. So numbers that are greater than 6, like 7, 8, and going upward, it's not possible that you will throw a single die and you obtain any number that is greater than 6. So the event actually is 0 because that does not exist. So it means the probability of obtaining a number that is greater than 6 is equal to 0 divided by 6, and that is actually 0, or better still is the same as 0%. So as we said in our previous lesson, a probability of 0% means it can never happen. So that can never happen for you to throw a single die and obtain a number that is greater than 6. It's not going to happen. Okay, so let us see another problem. Suppose you throw two fair dice. What is the probability of getting A, two equal numbers, B, two factors of 20, C, at most one prime number? So you have two dice, two fair dice. So when you throw two fair dice, how many possible ways, how many possible outcomes can be generated from those two dice? Okay, so what we will want to do is to draw a table, and you will have the first dice which has 6 numbers, so from 1 to 6, and the second die also from 1 to 6. So what will happen is when you throw the dice, there's a possibility that this one will be will turn up with either of the 6 numbers on the second die. Okay, so it means it's possible that you could have 1, 1, 2, 2, all the way to 1, 6. That could be a possibility. Okay, so it means on the first die you could have 1, then the second die you have 1, or you have the first die 1 or 2. And similarly, there's a possibility that 2 could show up with any of these numbers on the second die. So you will also have 2 and 1, 2 and 2, 2 and 3, continuing. So all of these outcomes could be possible. So it means we have about 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 times 6 is 36. So it means we can have 36 different outcomes. So we say the outcome is equals to 36. All right. So let us see. A says 2 equal numbers. So what's the probability of obtaining 2 equal numbers? So now that we know that the total number of outcomes is 36, what we need to also do is, for each of these problems, we need to determine the event. So what's the possibility? How many possibilities that we can have 2 equal numbers? That becomes the event for A. So let us see. So we have 1 and 1 are equal numbers. So it means on the first die you have 1, the second die you have 1. These are equal numbers. 2 and 2 are equal numbers. 3 and 3, 4 and 4, 5 and 5, 6 and 6. These are the possible, ways that we can obtain equal numbers. Because if you see here, this is 6 and 1. 6 and 1 are not equal. So the only possible ways that we can obtain equal numbers are those values that we have here along the diagonal of this chart, of this table. So we have 1, 2, 3, 4, 5, 6. So those are 6 different ways that we can obtain numbers that are equal when 2 dice are thrown. Okay, so we say the probability of obtaining 2 equal numbers is equal to 6 divided by 36. And 6 divided by 36 is 1 over 6, or possibly this is also equals to 1 over 6 is the same as 16.7%. Okay, it's 16.7%. All right. Okay, so let's see B. B says 2 factors of 20. 2 factors of 20. So one thing we need to determine first are the factors of 20. So for the factors of 20, we say the factors of 20 are, we know that factors are 2 numbers that you can multiply to obtain the product. Okay, so those 2 numbers that you multiply to obtain the product are the factors. So you can have 20 times 1 to equals 20. And you can have 2 times 10 to equals 20. You can have 4 times 5 to equal 20. Okay, so those are the numbers that we can multiply to actually obtain 20. So it means the factors of 20 are 20, 1, 2, 10, 4, and 5. But if you look on the dice, the factors of 20 that are on the dice are 1, 2, 4, and 5. Okay, so the problem is saying two factors of 20. So let's see what's the possibility of obtaining two factors of 20. All right, so we say 1 and 1 are all factors of 20. So these two are factors of 20. 1 and 2 are factors of 20. 1 and 3, no. 1 and 4 are factors of 20. 1 and 5 are factors of 20. 1 and 6, no. So if you look here, then we come here 2. So we always also we have 2 and here 2 and this 2 and 4, 2 and 5. 1 and 3, 1 and say okay. So once 3 is here, then it means it cannot form part of it. 4, okay, 1 and 4, or 4 and 1, 4 and 2, 4 and 3, 4 and 4, 4 and 5, okay, 5 and 1, 5 and 2, 5 and 4, 5 and 5, yes, okay. So those are the only possible ways. So we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 different ways that we can have two factors of 20. Okay, so our event for obtaining two factors of 20 is 16. Okay, so it means the probability of obtaining two factors of 20 is equal to 16 divided by 36, which is equals to 16 divided by 36 is just 4/9, because 4 into 16 is 4 times, 4 into 36 is 9 times. Okay, so 4 divided by 9 is the same as 44.4%. Okay, so we have 44.4% chance of obtaining two factors of 20 when two dice are thrown. Okay, so let us look at C. And C says at least one prime number. Okay, so what we need to do first is to know the prime numbers among these numbers. Okay, and we know prime numbers are numbers that have only two factors. Okay, so let's say for example 2. Okay, 2 is a prime number because in order to obtain 2, it must be 2 times 1. Okay, it must be 2 times 1. You cannot multiply any two numbers to give you 2. Okay, 3 is the same thing. 3 times 1, 3 times 1 will give you 3. No two other numbers that can be multiplied will give you 3. But 4 is not a prime number because you can multiply 4 times 1, you get 4, and you also multiply 2 times 2 and get 4. So once that happens, then it's not a prime number. Another number among these is 5. 5 is the same as 5 times 1. That's the only way you can multiply two numbers to give you 5, two whole numbers. So it means the prime numbers among these numbers are 2, 3, and 5. Okay, so the problem says at least one prime number. Okay, so 2 is a prime number, so at least one prime number, so this will form part of it. And 3 will form part of it. This cannot form part of it. Okay, this will form part of it. Okay, then we come here. 2 is a prime number, so it form part of it. Here, both of them are prime numbers, so it form part of it. The problem say at least one prime number. It means if 2 of them are prime numbers, they also form part of that set. Okay, yeah, both of them here are prime numbers. They form part of it. Yeah, we have one prime number here, form part. We got one prime number forms part. Okay, this form part. Okay, so here 3. Once we have 3 in me, will form part of it. So this entire column here will form part of it. Okay, this entire column will form part of it. Here the column of 5 will also form part of it because 5 is a prime number. Okay, so the entirely form part of it. Okay, then here 2 is a prime number, it forms part of it. 3 is a prime number, it forms part. 5 is a prime number, it forms part. Here too, 5 is a prime number, it forms part. 3 is a prime number, it forms part. 2 is a prime number, it forms part. Okay, so these are the prime numbers. So all the rest are not, prime numbers. Okay. All right. So what we're going to do now is to check how many of them. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay, so it means our event for obtaining at least one prime number when 2 dice are thrown is 27, because we have 27 different possibilities of obtaining at least one prime number on any of the dice. So it means our event is 27. So the probability of obtaining at least one prime number when 2 dice are thrown is 27 divided by 36. And 27 divided by 36, 9 into 27 is 3 times. Okay, 9 here is 3 times, and 9 here is 4 times. So you will have 3 divided by 4, and 3 divided by 4 is just equals to 75%. So we have 75% chance of obtaining at least one prime number on either of the dice. Okay, so that's just it, and thank you.